Okay, so maybe they will join slowly. Anyways, I should record even if everybody is there. I've started recording. Fine. Yeah, I forgot actually to record. Okay, so we were discussing all this. So we found out that there are 7 and minus 2 operations. So what was the problem? The problem was that we wanted to find the maximum element in an array, and in the worst case scenario, we said that it is going to be 7 and minus 2 algorithm. This is the 7 and minus 2 operation. This was the time. So this line takes two number of operations. Next line, this for loop is done 1 plus n time. How it comes? One is for I is assigned to 1, and then there are comparison operations. There are n comparison operations. Though we say that n minus 1, right? But when i's value is 1, 2, 3, when it becomes n, when it becomes 2n minus 1 means n minus 1 it has to take. But when I becomes n, then also there will be a comparison operation to find out that n is not less than n minus 1. So that's why we got totally n comparison operations, and this one is for I is equal to 1. And then every time I is incremented, that we have considered here. That's why we have just put it in the curly brace, but this is not part of the algorithm. When we say increment counter I is I equal to I plus 1. So there are also two operations, right? And how many number of times this will happen? This will happen n minus 1 times. So like that, we had calculated the total number of operations. This is what we were doing in the last class. And then current match becomes AI. Again, there are two operations. AI is 2 and it is assigned one. And AI is one operation, assignment is another operation, two operations. And this is going to execute, which is inside the for loop n minus 1 time. But this line will be executed when, in the worst case. Right? So what you are doing is initially you are saying that current max becomes A0, and then you actually compare the current max with starting with A1, A2 till AN minus 1. Right? So, and if you find that AI is greater than the current max, right? So current max becomes AI. Simple algorithm for calculating the maximum of an array. Now, this line executes every time, right? This line executes every time when, your array right? If the array is given in the increasing order, then every time this line is going to be executed. Every time this line will have to do one operation. That AI will replace the current max. Okay, so this is the worst case scenario, 7 and minus. Okay. Now, if I say it's a best case scenario, that means best case scenario will be when the array is given in the decreasing order, right? That means A0 itself is the maximum element. But still, we will have to check. This line will execute. AI is greater than current max. But what will happen? It will never enter into the decrease. So this line is not executed. So, the best case will be when your first element itself is the maximum element and the array is given in the, so basically when the array is given in the decreasing order, right? So tell me, quickly calculate and tell me what is the complexity for the best case. Just add it up and tell me. You should keep a pen and paper, students, with you in this class always. Okay. So it is going to be 2 plus 1 plus n plus 2 n minus 1. This 2 n minus will not be there. Plus 2 n minus 1 plus 1. So quickly tell me how much it is going to come. Yes, students, I am waiting for your answer.
Excuse me, ma'am.
Yes. Yes.
From your side. So can that be minimized? Like in the last meeting also there was some disturbance.
In the last meeting also?
Some noise is coming there, ma'am.
Now also is it coming? But now I have perfectly set up everything, students. Maybe
Ma'am,
you
can you try one thing? At least can you go to the device settings and change the noise suppression to high?
how to do
Maybe
that? Okay, tell me how to do that.
go to Teams and there will be 3 dots, no, ma'am.
Okay, I am doing it. Yes. Here, that is, yeah. Here or here, this top one, more action.
Yeah. 1 minute, I will.
Device
There will
settings.
be device.
Okay.
Yes, ma'am. There will be noise suppression.
Yeah.
Actually, there will be we will be given an option to choose from whether to put high, automatic, or low. Can you toggle it once on and off?
This is off. So this is noise separation is off, right? And now it is on.
Okay, ma'am. I
Right?
think Teams. Yes, ma'am. My team shows different. I have an option like high and auto. So maybe we cannot decrease the noise.
Okay. So what noise you are? So continuously is some sound coming? Is it only for you or for everybody?
Ma'am, for remaining people also. Ma'am.
Even I'm facing the same thing.
So you can hear some sound, is it? Okay, I will do one thing. I have a fan that is on, so I will just switch that fan off. There is no other noise in this room. Let me just try that out. Yeah?
Ma'am, the sound suddenly increased. Maybe some connections to the laptop, I think, like the noise suddenly increased, ma'am. Maybe you can check that and try to avoid. Uh,
Okay. Just now you were saying.
You leave the settings, ma'am. The fan or the laptop sound, it's hardware sound, I think.
Oh, is it? Okay. Um, okay. Okay, let us see. Okay, let us try this out. Now again, this is noise is there.
Yes, ma'am.
Okay, I will leave and then join again. Let us see. Hello. Uh, is it better, students, now?
Yes, ma'am.
Yeah, because now I'm using my microphone. Okay, I hope it will, it should help. So let us see. Should help. Yeah. Okay, so where was I? Yes, so I was asking you to calculate the. I was asking you to calculate the best case scenario time. Okay. So please do so. This is the algorithm. So we said that we are finding out the maximum element of the array. Okay, and now if I say the best, obviously the best case scenario will be the array is, the input array is given in the decreasing order. So what will be the time? What will be the total number of operations when the array is in decreasing order? Okay, so can you just quickly tell me? Anybody can tell me, yes. So we will, so if it's a best case scenario, we are not going to have this particular step, right? So this step will never be executed because what we are doing, we are making current max equal to A0 in the very first line. And every time when you do AI is greater than current max, this condition will not satisfy. So this line will never be executed, right? So rest all when you add, that will give you the best case scenario, right? So just add and tell me the answer, students.
5n, ma'am.
Yes, so it is going to come 5n. So I want all of you to be active students, okay? So in between I will ask questions. So and I expect a quick answer from you people, okay? Though it is there in slides, the answer is also there in the slides. And do not feel that it's a very simple problem, okay? So wherever possible, we are revising it. Definitely, you will realize that suddenly from the speed of cycle, we have changed the speed to the speed of car. Okay, but it will happen. Okay, but we have to ride this cycle. So we are doing all revisions. Okay. So though you know, you already know that we finally do not count these basic operations, but we must know that how to. If someone asks me to count the basic operations, I must know how to count the basic number of operations. Okay. So that is what. So if the number of primitive operations executed by algorithm array max is at least 5n. That's what you calculated just now, right? And at most, it is going to be 7n minus 2, right? So the best case is Tn equal to 5n. That occurs when A0 is the maximum element, right? So that variable current max is never reassigned. Not necessarily that the array is given in the decreasing order, that becomes the best case. The best case, the best case is when A0 is the maximum element, right? So among them, once A0 is maximum, that means you never have that exchange operation, right? Where you update the value of current max with one of the value of AI, right? And this is the worst case. Okay, because every time when the elements of the array are sorted in increasing order and current max is reassigned at each iteration of the formula, right? So basically, now when you talk about growth rate of running time, okay, how your running time of the algorithm grow. Okay, so what happens if you are going to change the hardware or software environment? Okay, so now if I have an algorithm that is running in a particular hardware software platform, okay, if you change the hardware and software platform, what will happen? The TN will be affected. Definitely it will be affected, but it will be affected by a constant factor. Okay, so suppose I say now I am using this particular machine which is a slow processor. If I run it in your machine, probably all the programs they may run in a less amount of time, but that will be a constant. So in my machine, if a program is running in 2 minutes, maybe in your machine it runs at 1 minute. Okay, but it does not alter the growth rate of TN. Changing the hardware and software is definitely going to change the overall running time. If you increase a processor, if you have a processor you can say efficient processor, better processor, your total execution time will be less. But we are talking about growth rate of the algorithm. That will not change. Okay, it does not alter, the machine does not alter the growth rate of TN. Okay, so the linear growth rate of the running time Tn is an intrinsic property of algorithm array max. So now if somebody asks you that if I change the hardware and software, will the growth rate of the algorithm change? So your answer has to be the growth rate will never change. Growth rate means with respect to the input. Okay, with respect to the input size, how the algorithm running time affects. Okay, but you know that if you want to compare an algorithm or if you want to compare two algorithms, you have to keep the hardware and software environment same, right? So if I am comparing two algorithms, algorithm A and algorithm B, I can only say A is better than B when both the algorithms are running in the same hardware as well as same software platform. You are using the same compiler, same operating system as well as the same processor. Then only you will say that A's speed is more or less than the speed of B, right? But so even if you change the hardware, the growth rate of the algorithm is not going to change. What exactly we mean by that? That if the operation is doing 7 and minus 2 operations, it will always do 7 and minus 2 operations. But doing one operation may take some amount of time based on a particular hardware or a particular software. But this number of operations that it is going to do 7 and minus 2 or 5n is not going to change. Okay, so that is why we are saying that growth rate is an intrinsic property of an algorithm for a particular algorithm. So how the growth rate of functions can be what all growth rates are possible. Many growth rates are possible. The popular ones are linear, quadratic, and cubic. Okay, what is this linear? Linear is, if you see, we are showing here a green line. Okay, linear means when your input is changing, with the same rate, it is corresponding to the input. So this is the change of the input, and this is the execution time. Okay, linear means, for example, if your input size is 1e plus 4, 1e plus 4 means 1 into 10 to the power of 4. This is a log chart. Okay, when the input size is very high, we use a log chart. So as you know that 1e plus 0 is 1, right? 1e plus 2 is 1 into 10 to the power of 2. That means this is 100. 1e plus 4 means 1 into 10 to the power of 4. 10 to the power of 4 means 10,000. Okay, 10 to the power 6 is 10 to the power 6. That is how we are showing it. Okay, so linear means this green line is linear. So now if you see 1e plus 4, so if the input size is 1e plus 4, the output is also 1e plus 4. Linear. 1e plus 6, it is 1e plus 6. Linear you can show as n also. So if this is n, the output is also growing with the rate of n. So 1e plus 10, you will see it is 1e plus 10. Okay, now this red line is quadratic. Quadratic means, now if quadratic means 1e plus 0 is 1. For 1 it is going to be 1 only. 1e plus 2. Okay, square. Square means now it should be 1e plus 4. So 1e plus 2, if you see, it is 1e plus 4. 1e plus 4 means 10 to the power 4 square. 10 to the power 4 square is 10 to the power of 8. So 1e plus 4 is going to be 10 to the power of 8. 1e plus 6 is going to be 10 to the power of 12, right? It is 10 to the power 6 means it should be 10 to the power of 12, like that. So this growth rate is your quadratic growth rate. Similarly, this is your cubic growth rate. Okay, cubic growth rate, if you see, 1e plus 10, that is 10 to the power of 10. 10 to the power of 10 to the power of 3, that means 1e plus 30, right? This is your 10 to the power of 30. So this is the cubic growth rate. So this graph has been shown to you to so that you analyze it, how it is changing, what is the growth rate of the algorithm. So this is the growth rate. These, how to draw these plots, these all are going to be important. All of you have started with your projects now, right? So you are comparing two algorithms, the growth rate of two algorithms. So we must know that, okay, based on this, we must know to represent it in two axis format. One axis, x-axis, and y-axis, how we are plotting it. Okay, so this is a log chart. So what happens here is the slope of the line corresponds to the growth rate of the function. This is just a representation. Okay, so linear, quadratic, and cubic. So the growth rate is not affected by the constant factors or lower order terms. You already know these concepts, right? So when we talk about a growth rate, even if you have constant factors or you have lower order term, what do I mean by lower order terms or by constant factors? So let's take an example. So suppose you have this example, 10 square n. 10 square n means 100n plus 10 to the power 5. This is a constant. Okay, now this is 100n plus 10 to the power 5, you can call it as a constant. This is a linear function. Okay, linear function means here the highest order is n. So you already know You can also represent it as ON, right? So how it is linear? So if you knew that linear was this, right? Linear was exactly n. So 1e plus 8 should, in the y-axis also, it should be 1e plus 8. Now if I try to plot, when I try to plot this 100n plus 10 to the power of 5, it comes something like this. When I try to plot 100n plus 10 to the power 5 exactly, it comes these dotted green lines, right? So because there is a constant factor, 10 to the power 5 is constant, okay? So and this 100 also is a constant. So the plot is going to be something like this. Now, what do you observe from this plot? Can anybody say what is this plot telling you? Okay, let me discuss the second example also, then you can answer. Okay, now if I see the third example, the second example is 10 to the power 5 n square. So 10 to the power 5 is a constant factor, n square. N square is growth rate is quadratic, plus 10 to the power 8 again is a constant factor, n is linear, right? Now you know what we are saying is the growth rate is not affected by lower order terms. Now if you see these two terms, 10 to the power n square over powers n, right? So if you compare these two, then this n becomes a lower order term. It is a lower order term, right? So, and n square is the higher order term. So if I consider this as n square, if you say that the answer, this is O(n) square, right? All of you will say that it is O(n) square. But if it was O(n) square, it should have been like this. This is the quadratic line. O(n) square, you already saw this is a quadratic line. Now what I try to do is, I try to draw this one. Exactly this one, 10 to the power 5n square plus 10 to the power 8n, like this when I draw. So what is our observation by this dotted line as red and the dotted line as green? What is the observation? Anybody can tell. Clear cut you are seeing, no? Something. Just by seeing the plot. Am I audible, student? Yes, Shruti, are you there? You can answer this question. Yes.
Yes, ma'am.
Yes. Anybody can answer this question. Whoever has unmuted now, you can please answer.
Ma'am, the difference is the constant.
The difference is the
The constant. In the linear case, the constant is the addition of 10 to the power of 5. So,
okay.
but when we consider the overall time complexity, we neglect that constants.
Okay.
Actually, if you see the graph, linear is a straight line, which is a 45-degree line, but
Mm-hmm.
due to the constant 10 power 5 and the 10 square before the n, 10 power 5, we increase, the y value starts from 10 power 5. That is the difference.
Okay. Yes. 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 So basically, Yeah. Fine. So good. So what basically we are seeing is when you go. So basically, if you ignore when you ignore the the value of n when it is small. Okay. This is the place when it is small, right? When it grows more, when the value of n becomes more, then you see it is, this is parallel to your quadratic plot, right? It is parallel to your quadratic plot. Similarly, this is parallel to your linear line. If you try to see the slope, then the slope with the x-axis is going to be same. Okay, so definitely, the starting point, when the value of n is less, there is a more effect. But when the value becomes more, it tends to behave in a similar fashion as your quadratic line. Okay, so when the value of n, see, it is parallel with your quadratic line. When the value of n is more, it becomes now parallel to your linear line, right? So that is what we have learned, right? So far we have learned that when the value of n is more, you can ignore these constants, right? Because now if you try to plot, you will see this looks like similar to your quadratic curve, right? This is similar to your linear curve. Okay, so that is why you remove the constant factors. You don't consider, and you do not consider the lower order terms as well. right? So now similarly, so now what we have learned is we talk about the big O notation. Okay, so what is big O notation is? Big O notation tells me that there is a function. Okay, there is a function existing. A function gn is there such that my function fn cannot grow more than gn. Okay, gn gives you the maximum limit. Okay, so if you have been given two functions, given functions fn and gn, both of them are given, we say that fn is O of gn. Okay, Fn is big O of Gn if there are positive constants C and N0 such that Fn is less than or equal to C of Gn. Right? That means Fn will always be either less than or it will be equal to Gn. Okay, with but there should be some positive constant. Some positive constant means C cannot be 0. C has to be greater than or equal to, you can say greater than 0 or you can say greater than or equal to 1. Some positive constant. Okay, C and N0, and there should be N0 also, that N is greater than or equal to N0. There should be some constant N0, right? Such that your N is greater than or equal to N0. Okay, so if we are able to find such constant, then we say that Fn cannot grow more than Gn. This is what this definition says. Fn is less than or equal to C of Gn means Fn at any time cannot grow more than Gn. Fn can grow equal to Gn because it is less than or equal to, right? Fn can grow less than or equal to Gn. The growth rate of Fn depends on the growth rate of Gn such that the Fn will never grow more than the rate of Gn. Then you say that, okay, this is the upper bound. Okay, why I am using this term is big O always represents the upper bound. So how much my Fn can grow? Fn can grow at the maximum how much Gn can grow. Okay, like that. So for example, suppose you say that your 2n plus 10, you know that it is O of n, right? You know the simple rule that I will remove the constant and I will remove all the constants, so I will call it as O of n. Why we call it as O of n? Now if you see, if it is a true n in a log scale, this is going to be n, line of n. Okay, and this red line, this red dots are the line of Cn. Okay, and 2n plus 10 comes like this. So this blue line is 2n plus 10, right? So what we say is so why are we plotting 3n is because we are applying this particular thing. Now to prove this, that Fn, we want to prove that Fn is less than C of Gn. Now what we want to do is 2n plus 10 is O of n. So if I have to prove this is my Fn, this is my Gn. I have to say that 2n plus 10 is less than or equal to C of n. Right, wherever possible, students, you should use your pen also, okay, so that it helps you to recollect. So you don't need to read again the slides once you do it. Okay, so 2n plus 10 is less than or equal to Cn. So that's how you find out that you take this to the right side. C minus 2n is greater than or equal to 10, right? Then you get n is greater than or equal to 10 divided by C minus 2. Now with brute force approach, with trial and error approach, you try to find out what could be C. So one simple thing could be, this is coming at the numerator. So let me say C minus n. So let me make it as 1. So 10 by 1 if I want to make, let me take C as 3. Right? So this is C. If I take C as 3, it becomes 1. Right? So n becomes greater than or equal to 10. So n has to be greater than or equal to 10 because I do not want to make it as negative quantity, or I do not want to make this as 0, right? So I take C as 3. So 3 minus 1 becomes 1. So n should be greater than or equal to 10. And as per this condition, my n should be greater than or equal to n0. So with this, we found out that n0 should be equal to 10, right? So if my n0 is 10 and C is 3, okay, so then I can say that Fn is less than or equal to C of Gn. So I found out that Fn is less than or equal to 3 of Gn, C of n, right? So if I want to assume that it is On, so am I able to find a constant C? Yes, I am able to find a constant C. The value of constant C is 3. And am I able to find a constant N0? Yes, I am able to find a constant N0 such that N0 is 10. right? So if I do that, then this Cn, C of Gn becomes 3n, and 3n's plot comes like this. Okay. Now what do we understand? We say that 3n, so just to tell you that Fn cannot grow more than 3n. Where is my Fn? Fn is this, 2n plus 10. It cannot grow more than 3n. So 3n will always be growing more. 3n is always growing more than your 2n plus 10. Okay, so and you know why? So but you are also saying that n0 is equal to 10. Beyond 10 only, you are not saying that it is. So that is taking care of this initial value also. Now if you see initial value, when 3n was starting from here, right? The value of 2n plus 10 growth rate was more, right? But at the end, what happened? If you see after this line, when your n0 has become 10, your this 3n is growing more. Here, if you say the growth of 2n plus 10 is more initially, but later on you see that the growth of 3n is more. So that's what we found out, that 2n plus 10 cannot grow more than 3n. Okay, you already know these things. I am trying to tell you the idea behind n is greater than equal to n0. Right? So n has to be greater than or equal to 10 here. Because if n is less than or equal to 10, you will not be able to say this, that Fn is less than equal to C of Gn, because that is what you are showing from the plot. Okay, so that's the importance of finding out a constant, as well as finding out two constants, C as well as n0. Okay, so beyond that, after that, you need to apply this constant C, and you need to have n is greater than equal to n0, such that this condition satisfies. And why do we go for this? Because when we try to calculate the algorithmic complexity, we actually see it when the value of n is very, very large. That is why we consider the scenario when the value of n is large. So these lower side scenarios we try to ignore. But we need to have the constant C and n0. That is the importance of having C and n0. That's clearly seen by the plot. Okay, it is there in your book as well in section 1.2. So this is the concept of significance of big O notation. Okay, all of you know all these things. Okay, so another example is, now we want to prove that n square is not O of n. You already know that, right? Example function is, n square cannot be O of n, big O of n, because the growth rate of n square will always be more than n. But if this was true, right? If I'm saying that n square is O of n, that means I should be able to find out something like this, that Fn is less than or equal to C of Gn, right? If it was true, if I assume this was true, then n square should be less than or equal to C of n. Then I will get that n should be less than or equal to C. This is a contradiction, because what I say is, I say that C has to be a constant. So suppose I fix C as 1000. Constant means I cannot keep on changing C, right? So if I say C as 1000, then n will be less than equal to C till the value of n doesn't grow till 1000. But once n becomes more than 1000, this inequality will not satisfy. Okay, so that is why n square can never be On. So this is proved with the graph also. This, this is the plot for n. This blue line is for n square, right? And this red dotted line, so this is for 10n and this is for 100n. Okay, so we can never grow. So, whenever you try to plot a line for n, 100n or whatever n, this line will come like this. Okay, and n square is going to come like this. So now if you compare, this blue line, that is n square, with this dotted line. So it is somewhere, it is correct. It is coming correct, isn't it? If you see this blue line, it is growing with the less rate of 100n, but at this point it stops. Right? If you want to prove that, you will have to change the value of constant C every time, but that we are not supposed to do. We have to say that for a particular constant C. So every time we are not going to get such kind of a plot. So that is why this is not correct. You can always prove it by saying that this inequality you cannot satisfy. Okay. So some more big O examples. Okay. So quickly, please try to do that in your notebook, students. Okay, because what is there, you know the answer. If I say what is 7n minus 2, all of you know that this is going to be O of n. But how? If you are saying O of n, you also should say that what is the value of C and what is the value of n0. That is very, very important. Okay, so 7n minus 2 is On, but you need to have C has to be greater than equal to 0. C has to be greater than 0. Okay, and n0 is greater than equal to 1, such that 7n minus 2 is less than or equal to C of n. So that's what you know. So Fn is less than equal to C of n for n is greater than or equal to n0. So rather than, so we can write n0 as n0 is greater than 0. It's a positive constant, or I can also say that n0 is greater than or equal to 1. To say that n0 is not 0. Okay, so that is specific about C and n0. What is that? That they both are positive constants. Okay, so they both are positive constants, wherein we say that C has to be greater than 0. That means same thing I could have written as C can be greater than or equal to 1. Okay, so two different notations we have done just to tell you that these are the same thing. We say that C and n0 are positive constants. Okay, so C has to be greater than 0. That means C is greater than equal to 1. Or similarly, n0 can be greater than or equal to 1. You don't keep C as 0 as well as n0 as 0. Okay, such that Fn is less than equal to C of n. For n is equal to n is greater than or equal to n0. So you need to find out the constant. So this will come if you try to do that. Let us keep C as 7 and n0 as 1. So if you keep C as 7 and n0 as 1, so this is going to be 7. So 7 and minus 2 is, so n if you keep as 7, so 7 and minus 2 is less than equal to 7. Right? Obviously, because if you are keeping n as 1 minimum value, so it is going to be 7 minus 2, that is 5 is less than 7. Okay, so we try to find out the minimum value, right? We try to find out the minimum value for C and as well for n0. Otherwise, there are many answers that can be true, right? So if I ask you what will be the value of C and what will be the value of n0, you have to find out the minimum value that satisfies this inequality. Right? Why? Because you want to make C is a positive constant and you have a condition that n should be greater than or equal to n0. So you have to find out the minimum value for n0. Okay. Similarly, you know that 3n cube plus 20n square plus 5 is going to be on cube. Right? Why? Because we leave the constant term, you know, and we also ignore the lower order term. So the highest order term is n cube. So it is going to be on cube. But you need to prove this. C should be greater than 0 and n0 should be greater than or equal to 1. Fn is less than equal to C of Gn. So you need to keep, so this comes using trial and error. Right? So if you put C as 4 and you put n0 as 21. Okay, so it's like solving an equation for minimum values, right? So what you do is 3n cube plus 20n square plus 5. You know, if I ask you what will be the value of n0 and c equal to 4, okay, so you may have to go back to your solving the mathematical inequality, right? So minimum values you can keep. So so minimum value of c you can start keeping as 1, then you go for 2, then you go for 3, and then you see when it is going to be satisfied. So you get a value of C is equal to 4 and N0 is equal to 21 to get this one. Okay. Now 3 log n plus log of log n. All of you know that here what is the higher order term? It is log of n. What about log of log n? If you see the value of log of, so log, whenever you do of something, you get a less value. No? So log of, let us say this is log of log 4. If it is log of log 4 is 2 to the power of 2. And you by now you must know that when you simply say log, it is considered as base 2. Okay, when you only say log, it is base 2. So now if I try to calculate log 4, log 4 means 2 to the power of 2. So the answer is going to be 2. So I get here log of log 4 will be log of 2. Log of 2 is going to be 1, for example. Okay, and then if you see 3 log n, it is going to be log 2. 3 log n means it is going to be log 4. Okay, so this will log of n will be always smaller than log n, right? So you know that the answer is going to be O of log n here. Okay, but if you want to find out C and N0, you need to prove that. So you need to find a C that is greater than 0 and N0 should be greater than or equal to 1. Okay, so Fn is less than equal to C of log n. So if you keep C as 4 and N0 as 2, okay, if you keep C as 4 and N0 as 2, you are able to satisfy the inequality this one. So we try to keep the values minimum. So you kept N0 as 2 because you know this is base of log 2, you know. So if you keep N as 2, I was telling you to keep N as 4, okay, but we are trying to find out the minimum value. Okay, so if you keep it as 2, so log 2 is going to be 1 and then log 1 is going to be 0. We are trying to keep the minimum value that can satisfy my inequality. And again, if I put it here, then log 2 is going to give me 1. So this is going to give me 3. Right? So this side is going to give me 3. Right? So this, if I put n is equal to 2, this left hand side is giving me 3. And I want to prove 3 is less than or equal to C of log n. Okay, so log n, log 2, if I do, it is going to be 1. Right? So 1, so C dot 1. So what should I should keep a value. So I pick up C as 4. Okay, because then it is going to be less than or equal to. Can I keep C as 3 also here? I think that will also work. C is 3 is also going to work here. You should be able to do these calculations, students. So along with me, when I am doing this, you should do the calculation for this as well. Okay. So we know the big big O and the growth rate. Okay. So big O notation gives what we understood from those plots is that big O notation gives an upper bound on the growth rate of a function. Okay, so I mean to say that the statement whenever I say Fn is O of Gn, it means that the growth rate of Fn is no more than the growth rate of Gn. Fn cannot grow more than Gn, but Fn can equally grow as Gn because it is less than or equal to. Okay, so we can use big O notation to rank functions according to their growth rate. Okay, so big O notation can be used to rank functions according to their growth rate. So now here we have made a small chart. We have said that Fn is O of Gn and here we are saying Gn is O of Fn. Now suppose it is written Fn is O of Gn. Okay, so now when I say Gn grows more, I am saying that Fn is O of Gn. Right? Fn is O of Gn. Does it indicate Gn grows more? Yes, it indicates Gn grows more. Does it indicate Fn grows more? It says no. Okay, if Fn is O of Gn, that means Fn grows more? No, Fn cannot grow more than Gn. But does it say that Fn grows same as Gn? The answer is yes. Okay, what we are trying to say is Fn is O of Gn means Gn grows more and they may also have the same growth because Fn is less than or equal to O of Gn. Okay, similarly, if it is given Gn is O of Fn, now it is given the other way around. Gn is O of Fn means Fn grows more. Okay, Gn is O of Fn. Does Gn grow more? No. Does Fn grow more? Yes. If Gn is O of Fn means Fn grows more than Gn. Okay, and do they have same growth? Yes, they have same growth. Okay, that is what it means. And what are the big O rules? Okay, that we have already known. Okay, so we are seeing those rules. So the first rule is if Fn is a polynomial of degree d, okay, then Fn is O n to the power of d. Right? That's what we use so far. Polynomial of degree d means it's a polynomial which has terms like n to the power of something. Okay, so that means it has terms like this, O n to the power of d. So what is the rule? The rule is we are going to drop lower order terms and we are also going to drop the constant factors. Okay, another rule is we are going to use the smallest possible class of function. Okay, so what we are saying is we are saying that 2n is O of n. But actually if you see 2n is O of n square also. 2n is O of n cube also. Because the meaning is when you say 2n is O of n means 2n is less than or equal to C of n, right? But the same thing can be said as 2n is less than or equal to C of n square, because n square grows more than n to the power n grows more than n. But the rule is we are going to use the smallest possible class of function, right? So you will not say that 2n is on square, you will say that 2n is on. Though 2n is on square is also correct. That is also correct. If you try to draw a plot, that is also correct. But that is not the rule. When you say the algorithmic growth, you use the smallest possible class of function. Okay, that is one of the rules. Okay, use the simplest expression of the class. For example, you will say that 3n plus 5 is on. You will not say that 3n plus 5 is O of 3n. Okay, we try to make the expression as the simplest expression. All right, so we will continue with the class, students, in tomorrow. Okay, we'll continue with this. Okay, I hope you are not getting bored, though you may find this as repetitive, but we need to do all these things quickly because this is forming the base before we go to the complex problems. Okay, so in tomorrow's class we will also discuss one more algorithm, that is finding the prefix average. Okay, so another, again we will try to calculate the basic operations, but now we will not try to see each of the basic operations. Okay, we will use these rules and then we will compare two algorithms. All right, so I wind up here, students. Was I audible? Was there the noise, or this was fine, students? Just tell me.
This is fine, ma'am.
Okay, so I got to know that I need to use this microphone, then it is fine. Okay, so it won't be a disturbance tomorrow's class. So thank you, students. We wind up here, and I have uploaded the course plan, and I will upload by tomorrow. I will upload this lecture 1 as well. We will be able to complete lecture 1 tomorrow's class. Okay, so thank you, students.
Thank you. Thank you, ma'am.